Okay, so this is the first of the videos on material from the lecture notes. And this video is really just to get us going. We're going to define some notation and define what we mean by multivariate data analysis. So we're going to think of data as coming in a matrix X, which is typically going to be n by p. The way we think about this is that we think we've got n cases or subjects, and we've got p variables or measurements. So subjects, for example, might be people, and measurements might be things like the height, the wealth, whether they have COVID, etc. Or, let's delete them to pick a different example. Cases might be countries. Okay. And the variables and measurements might be things like GDP, life expectancy. Okay. So the cases are the countries, and the variables and measurements are things we record about those countries. So we record it for France, for China, and so on. Or one final example, let's suppose we've got a bunch of images. So our cases might be different images. And the variables in that case might be things like the pixel intensity for each of the pixels in the image. We'll see more about images later. Okay. So we're going to put our data into a matrix which I'm going to call capital X. So it's going to have n rows and p columns. So each row represents one subject or one case. Okay. And each column represents one type of measurement or variable. So we often use lowercase x, let's say xi, to be the measurements for subject I. So if we've got p measurements, we have that xi is in, if they're all real numbers, it might be in rp, for example. Although they don't need to be real numbers, they might be integers, or they might be labels, or who knows? Okay, we'll see examples later. So we said the rows of x correspond to each subject, so we will have x being the matrix where the first row is the vector x1 transposed. I write transposed here to indicate it goes across. The second row will be x2 transposed, and down to the nth subject xn transposed. We can also think about it in terms of the variables. Okay, so you could write this with variable 1 being the first column, variable 2 being the second column, down to variable p, it should be, being the pth column. Okay. Where for each variable we have measurements on all n subjects, so each vi is in Rn, or is of length n. They might not be real numbers. So just a brief remark on notation. Throughout the module, I'm going to try and write vectors will be lowercase and bold, okay, in the printed notes. But when I write them in handwritten notes, I'll underline them to indicate they're vectors. So things like X with a line underneath it. But in the printed notes, they'll be bold text. Okay. Scalars will just be lowercase, and matrices will be uppercase and bold. Okay. So like capital X. Now when I write them in the notes, I tend not to underline them, but I might sometimes if I remember. So X or X would both be a matrix. But in the printed notes, they are all in bold. So unlike in most of the statistics, I'm not going to use the convention that uppercase means random and lowercase is an observation. Okay, the uppercase here means matrix, and lowercase means scalar or vector. Okay? And they might be random or not random. Let's now look at some example data sets. Okay. We'll look at these over the next few videos. All I want to do now is introduce them and explain what the cases are and what the variables are. So the first example is some data from World Cup, Football World Cup. And we've got 4 teams, and the teams here are going to be our cases, or our subjects, if you like. So USA is one subject, England is another subject, and so on. Then in this page, we've got 4 variables as well. We've got the number of games each team has won, the number of games each team has drawn, the number of goals scored, or 4F, the number of goals against, A. So the data vector for USA would be number of wins, 1, number of draws, 2, number of goals scored, 4, number against, 3. Okay, so the vector 1, 2, 4, 3. For England, the data vector would be 1, 2, 2, 1. And so our whole data here is made up of this matrix. We may or may not choose to have the team names listed in our matrix. Another data set I want to talk about at various points is exam marks. Okay, so this is more a theoretical one than a real data set, but we could imagine, say, the second year undergraduate students at Nottingham. They take 1 module in probability and 1 module in statistics. So let's suppose we've got n students, and each one has a mark in probability, a mark in statistics. So the data matrix is an n by 2 matrix, because there's n students, n cases, so there's n rows, and there's 2 variables, so we've got 2 columns. Okay. And here I'm using xij to denote the jth variable on the ith subject. So it's kind of standard notation, xij for the ijth element of the matrix. Another data set we're going to see quite a few times is a famous data set used by Fisher, and it's used in many statistics textbooks. This is a data set that's built into R called the iris data set. So if you go to R and type iris, okay, it'll print the data set out for you. It's built in. So if we just print the top few lines here, we can see that there's various pieces of information given. We've got something called the sepal length, the sepal width, the petal length, petal width, and the species. So there's 3 different species here: Setosa, versicolor, and virginica. And for each species, we've measured the sepal lengths and widths and petal lengths and widths for 50 different flowers. So each case here is a different flower. So there are 150 flowers measured. So there's 150 rows in this table. And there's 5 pieces of information collected on each flower: sepal length, sepal width, petal width, and the species. And we're going to look at visualizing this data set in the next video. And the final data set I just want to introduce here is some image data. Okay, so this is a famous data set in machine learning called the MNIST data set. And what it is a collection of handwritten digits that have been scanned into a computer and converted to a grid of 28 by 28 pixels. So a pixel is just a single point in an image. Okay, so there's 28 pixels across and 28 pixels up. And for each pixel, they've measured the grayscale intensity. Okay, so whether it is white, black, or grey, or somewhere before, and how grey. And so in this case, we've got 60,000 images. So I've plotted 16 of the images here. Okay. And each image is a 28 by 28 grid. So if we flatten them, like there's a vector of length 784. So our data matrix X will have 60,000 rows and 784 columns. And each column corresponds to a single pixel in an image. Okay, so we'll come back to these data sets later. The question for now is, what are we going to be doing in this module? Okay. What type of analysis are we going to do on these data? What is multivariate data analysis? So the kind of questions we're going to answer and ask are things like, how can we visualize the data? How can we plot it to show the range and the variability in the data in a way that we learn something meaningful by looking at it? We might ask questions like, what's the distribution of the data? Yeah, so for the example where we had students marked, what's the joint distribution of their probability mark and their statistics mark? Yes, we've got two variables. How do they vary together? Another question is, can we simplify the data? Okay, for the football example, one way we often simplify the results is to say you get 3 points for a win and 1 point for a draw. So the USA would have 5 points, England would have 5 points, Slovenia would have 4 points, and Algeria would have 1 point. Okay, so that'd be one way of summarizing the data and reducing it to a single number. But there are many other ways. So we're going to think about ways of summarizing the data. Another type of question we might ask is, can we use the data to find subgroups? Yeah. Are there differences between these types of flower? Okay, between setosa and versicolor and virginica? In some way, can we discriminate between them? Okay. Can we build a model to say what the image is? Here. Okay, so can I build a computer model that reads one of these images, the pixel intensities from my 28 by 28 grid, and comes back and tells me, that's a 6, or that one's a 9. How do we do that? So most of the methods you've seen so far are kind of univariate methods. So you've got one variable that is of interest, one response variable. In this module, we're going to have multiple response variables, 2 or more. We're going to look for techniques for analyzing data where we have multiple response variables of interest.